Okay, so we all think we know what gravity is, right? But what if that classic image we were all taught in school, what if it has some pretty serious flaws? Let's take a little journey beyond the familiar and ask the big question. What really is gravity?
We've all seen this picture, haven't we? It's the classic explanation for Einstein's general relativity. You've got a heavy object, like the sun, making this big dip in spacetime, and planets like Earth are just rolling along the curve. It seems so simple, it feels right, and look, it's the bedrock of modern physics. But, that's what science is all about, isn't it? Asking the next question. And what's so fascinating here is that a few simple, almost childlike questions can start to make this whole picture look a little shaky. All right, so let's play detective for a minute and really look at this model. There are some questions you can ask that start to show the cracks in that old rubber sheet idea.
I mean, really think about it. The analogy only works on a flat, two-dimensional surface. The second you lift that bowling ball an inch off the sheet, its gravity's gone. Poof! But we live in a 3D universe, so right off the bat, we've got a problem.
And that kind of leads to an even bigger question. For this analogy to really work, the whole universe, from our sun all the way out to Pluto and beyond, would have to be sitting on one single gigantic cosmic sheet. But does that really sound like how a huge three-dimensional universe operates? And if you try to fix that by imagining, say, a bunch of sheets stacked on top of each other, well, the whole analogy just completely falls apart. A bowling ball on one sheet would have absolutely zero effect on a marble on the sheet below it. And yet, we know for a fact that gravity works in all three dimensions, connecting everything. And this is the real kicker. An apple on a tree, or you and me for that matter, we aren't rolling on some sheet deep beneath the earth. We're suspended way above it. So according to the analogy, the apple shouldn't even feel the curve. It should just float there. So why does it fall? All of these questions kind of scream that we might need a totally new way of looking at this.
So to even try to answer these questions, our source material puts forward a pretty radical alternative. It's called vector field theory, or VFT, and it basically asks us to just forget the rubber sheet entirely and rethink what reality is made of. Okay, here's the core idea, and it's a big one. Forget thinking about space and time and matter as these separate things. VFT says they are all just different patterns, different ripples in one single fundamental field. In other words, a planet isn't an object in space. The planet is just a stable piece of space. So this slide really shows you the huge shift in thinking. On the left, you've got general relativity, which says that mass literally curves and warps space itself. But on the right, VFT proposes something totally different. It says space is actually a fixed grid. But, and this is the key, the rate at which time passes can change inside that grid. So mass doesn't bend space, it slows down time. And that one change, switching from curved space to a variable speed of time, it completely reframes what we call gravity. It's no longer some mysterious pull from the outside, but something else entirely. Get ready for this, because it is a bit of a mind bender. According to this theory, you are not being pulled down into your chair right now. Instead, the particles in your own body are actually pushing themselves downward. But how? So here's how they say it works. Big objects, like the Earth, create what's called a time gradient in the space around them. All that means is that time ticks just a tiny, tiny fraction slower closer to the ground than it does, say, up at an airplane. Now picture a single particle in your body. The bottom of that particle is in slightly slower time than the top of it. Well, according to VFT, that tiny internal difference creates an imbalance, a sort of push from within, that forces the whole particle to move toward the slower time. So gravity isn't a pull from the Earth. It's a constant self-generated push happening in every single particle in your body. Okay, so with this new and kind of wild mechanical model in our heads, let's go back to those questions that broke the rubber sheet analogy and see if VFT can actually fix them. This was the big one, right? The paradox that the simple analogy just couldn't handle. Why does something floating above the Earth fall towards it? VFT gives us a really direct answer. The apple doesn't know anything about a sheet. Its own particles feel the Earth's time gradient right where they are up in the tree, and that internal imbalance is what creates the motion we call falling. Gravity becomes this local internal reaction, not some spooky action at a distance. And what about that whole 3D problem? The issue of gravity working in all directions, not just on one flat plane?
How does this new theory deal with that? And this is where the theory is actually really elegant. VFT just gets rid of the whole sheets idea completely. It's an unnecessary analogy. Instead, it describes a single 3D field where these time gradients exist everywhere, in all directions. So the mechanism works up, down, left, right, which perfectly solves the 3D problem.
Now, if you think that's a radical idea for gravity, well, you might want to buckle up because the PP behind this theory, they don't stop there. They try to use these same basic ideas to build a model for, well, for reality itself. It's a huge speculative leap, but let's just take a quick peek at what they're proposing.
The theory suggests that this fundamental field has multiple layers, almost like a fractal. And they propose these layers don't just correspond to physical space, but also to more abstract things like logic and even what they call metaphysics. It's a really ambitious attempt to create a theory of everything from one set of rules. And to show you just how ambitious this theory is, the authors even try to apply its vector principles to human behavior. I mean, look at this slide. It shows a proposed formula for analyzing political actions. Now look, this is highly speculative and totally unproven. A massive jump from physics to politics, but it just goes to show the all-encompassing scope they're aiming for. And you know, maybe that's the real takeaway here. Perhaps Newton's idea of a force and Einstein's idea of geometry, maybe they weren't wrong. Maybe they were just two different ways of describing the same thing, the what and the how of a deeper mechanical process happening inside every particle in the universe. So the next time you feel your feet planted firmly on the ground, just remember this core idea. You're not really being pulled down. You're experiencing an illusion, a side effect of time itself flowing at different speeds all around you and even inside you. And that's the thought I really want to leave you with. If one of the most fundamental, rock-solid forces in the universe can be completely reframed like this, what other parts of our reality are just waiting for somebody to ask the right question?